All right, today we're going to start chapter 3. Maybe get the whole chapter done today, I'm hoping. Anyway, chapter 3 is about water and its importance to life, okay? Water is what we call the biological medium. All the reactions that occur in living things, the medium that occurs in is water. And since we're 70% water, that works out well for us. We have all these reactions going on, our digestion, all of our thought process, all that. It's reactions that are occurring in our body. And we need a medium for it to occur in, and that's water. Okay? The one nice thing about water, it's the only common substance that you will find in all three states, physical states. So we have ice. Yeah, we'll see that soon, right? Winter's coming. We have liquid water, which is what water is at room temperature. And we have gas, clouds, all that good stuff. So water you'll find in all the phases all the time. You know, it's kind of a unique substance that way. The structure of the water molecule allows it to react. Remember, we talked about it being polar. It has a positive end and a negative end. It has poles. So even though its overall charge is zero, it's still, because the hydrogen's so small and the oxygen's much larger, you have a more negative end on the oxygen and you have a more positive end on the hydrogen. And because of that, it has these unique properties that make water is a unique. It's kind of like hydrogen is a unique element, while water is a unique compound. Okay, here's your lovely picture of our water and our swans, I think. Okay. All right. So we said that water is a polar covalent bond. In other words, it shares electrons, so it sticks together like a molecule. But because it doesn't share the electrons equally, you have these poles. You have a positive end and a negative end. And because of that, because of this polar molecule and these uneven charges, water is an excellent solvent. It dissolves things because it can pull things apart with its negative and positive ends. Okay? It allows the hydrogen from each water to also bond together so it sticks together more. It's more cohesive than a lot of substances. A lot of the properties, and we'll talk about some of the properties of water, come from this hydrogen bonding. Okay, so when you have a bunch of water molecules together, the hydrogens will bond with the oxygen ends. And so you'll get these patterns appearing with water. Okay, and here you can see it. Here we have oxygen with its negative end, and here we have hydrogen with its positive. So there's going to be a bond form there. There's going to bond form here, a bond form here. So you get all these different bonds so that water sticks together. And many of its properties of water is because of these bonds. Okay, so what are some super duper properties of water that make it so special for life? Okay, well, one of them is this cohesive, and that's what I was saying. It sticks together. If you've ever like watched water on your windshield when it's raining, and you know how the drops come and they stay together and they stay together, and then all of a sudden when they get big enough they fall, they'll stick together for quite a while before they'll fall. Water sticks to the sides of glasses. That's why we get that meniscus that occurs. Okay. Water is amazing for holding heat. Okay. We would be in big trouble without water, and we'll talk a little bit more about that in a minute. It expands upon freezing, which is weird. Usually solids become smaller when they freeze, but not water. And again, there's a reason for that, and we'll talk about that in a minute. And then they're an unbelievable solvent. Water will dissolve more things than any other substance. It doesn't dissolve everything. Organic solvents like non-polar, where they share and they don't have the poles, water doesn't work on them, like oils. But pretty much everything else, water will help dissolve. Okay? All right, so cohesiveness. When the hydrogen bonds hold those water molecules together, you get this cohesive. You know, cohesive means to stick together, and the water molecules really like to stick together. What that does, which is super important, it's not really important that the drops stick together on your windshield, but what is important for is in plants. They use that cohesiveness to allow the water to travel from the roots, where they absorb the water, and get it up to the leaves and wherever else it's needed. So they have to work against gravity, and cohesiveness of those hydrogen cells, or those hydrogen bonds, help the water do that. Okay. They have adhesive too. It's an attractive between the substances, again, the plant and the water cells. And I talked about that with the water, like when you put water in a glass, it actually goes up the sides a little bit. So that's adhesive, but cohesive and adhesive, kind of the same thing in this sense. But again, the big reason why that's important, how's the water from the roots going to get all over the plant? cohesion. And here it shows you how it moves up. It has to move against gravity, and it just sticks together. Here's in the actual cells and how it moves up. So again, without that property, we'd be in trouble because all our plants would die. Okay, and then they have water conducting cells. They're called xylem. We'll talk more about those when we talk about plants. All right, surface tension. Okay, because of these little hydrogen bonds that are formed, they kind of bond all together, so you have it's hard to break the surface tension of water. Okay, now for us, that would be like when you jump off the pontoon into the water, and that first bam in the water is, I mean, you got to make sure you're nice and smooth unless you're doing a belly flop, but that's why it hurts, because you have to break that surface tension. Now, you're going to break that surface tension because you're a little bit larger than like a bug or something. But if you look here, this guy can cruise along the top of the water. Here's your surface tension. Now, obviously, you can't see all the water molecules bonding together, but that's what's going on. So again, water has high surface tension due to those hydrogen bonds. And so you get that flow. And again, we have to break that surface tension when we jump in the water. And that's why it kind of hurts when you first hit that water, depending how far you're jumping off of. Okay. One of the most amazing things about water is it can hold heat. When you talk about specific heat is the ability of a substance to hold on to heat. Water is one of the highest. Okay. Metals are very, 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 very low, obviously, because they conduct heat. They allow it to pass through. But water, what it does is it absorbs heat from warm air and releases heat to the cooler air. Okay. Well, you're like, okay, so if it wasn't for water absorbing the heat during the day and releasing it at night, we would freeze to death as soon as the sun goes down. Okay. But that doesn't happen. We have kind of a steady temp, yeah, I know it gets cooler at night than it does during the day, but there's not that huge variance in temperatures. Because if you look at planets that don't have water, they get really, really, really cold at night and really, really, really hot during the day. We don't have that because we have water to moderate our temperature for us. It absorbs heat during the day and then releases it at night to make sure that we stay stable. Okay, so that's specific heat. And again, water has one of the high specific heats of all substances. It's the amount of heat that can be absorbed or lost by 1 gram. You can calculate it if you want. And if any of you guys have had chemistry 115, we did this. Excuse me. But the specific heat for water is actually 4.184, I think is what it is. And what it means is it resists changing its temperature. If you look at like aluminum and copper and the metals, theirs is less than 1. They don't hold on to heat. They don't want to. They want to let it go. So the water with its amazing specific heat is what keeps us from freezing to death when the sun goes down. Okay. If you look here along the water in California, look how nice the temperatures are. If you ever want to live somewhere where the temperature never changes, live in San Diego. But you see this, as you move out, it gets hotter and hotter as you move away from that water. But when the closer you are to the water, the nicer it stays because of this ability of water to absorb heat during the day and let it go at night. And there's only a difference of, maybe 50 miles here. Look at the difference. Okay. Another thing water does is when it evaporates, it takes heat with it. We know that when we work out, or for me, when I just walk really fast, we sweat. Okay. And when we sweat, what happens is our body produces, the sweat takes, when it evaporates, it takes heat with us, and that's how we cool down. So water's really great at that too. It has something called the heat of vaporization, and it's how much heat a liquid can absorb when it evaporates, when it's converted from a liquid to a gas. Okay. And we use it all the time we call it evaporated cooling. We call it sweating. But if we don't have that, so when a liquid evaporates, the surface stays cool because it takes the energy, the heat that was in that liquid, and transforms it and becomes a gas and, goes off into the air. So again, that's the process of sweating. If we don't have that, we're in big trouble. Okay. So it helps stabilize our body temperatures, and our bodies will naturally, when you get too hot, they sweat. And that's our way of cooling us off. Okay. Another great thing about water is when it freezes, it actually expands. And you're like, the most dense that water is when it's 4 degrees Celsius and it's still a liquid. Why would that be important? Think about if ice didn't float. Think about the lakes in the winter. If they froze from the bottom up, what would the fish do? For a couple days, you'd have easy fishing because the fish would all come up, but they'd all die. Everything in the water would die if it froze from the bottom. Instead, ice floats on top. So you've got the cold water down here, down below, and you've got ice up here. And, because of water doing that, we don't have to worry about losing all of our, organisms in the water every winter when it freezes. So, and water is one of the few things that does do that. Most things become more dense when they become a solid, but not water. Okay. Water's greatest density, I said, is at 4 degrees Celsius. That's when it's coldest. So if the ice sank, everything in the water would freeze. And then life on Earth would be impossible because we'd have no plankton. And plankton are kind of the basis of all life. Okay. So one of the things we're worried about right now with global warming is the ocean is a great sink, or it holds carbon dioxide, okay, and other greenhouse gases, but carbon dioxide is the big one. Because the oceans are getting warmer, then we've got issues because they don't hold the carbon dioxide. Then we got more, and then it gets hotter, and the cycle keeps getting warmer and warmer and warmer. Well, some people think, well, what's the big deal? Well, when the oceans get warmer, when we have hurricanes, the storms form, and over land, there's a lot of heat. But when it goes out over the ocean, the coolness of the ocean takes care of that heat. That heat is, the coolness isn't there anymore. It's too hot. And that's why we're having so many more hurricanes that are so nasty. I mean, think of all the hurricanes that we've had and all the damages they cause. And the other thing is because the oceans are getting warmer, they're starting to dissolve all the ice. And if the ice dissolves, then the ocean level rises, and then we're going to have some issues too. Plus, you always see the pictures of the poor polar bears. They jump from iceberg to iceberg. Well, if there's no iceberg, they jump out and they start swimming, and there's no iceberg, and the poor polar bears drowned because, they need a break, and there's no break for them to have. Okay? So we said that water is a solvent for life. Water is a solution. Okay, we talked about solutions before: homogeneous mixture, well-mixed mixtures. When you're making one, the stuff that does the dissolving is called the solvent. In most solutions, water is the solvent. The solute is what's dissolved. If we were talking about seawater, the solute would be salts. Okay, if you're talking about Kool-Aid, it would be sugar in the Kool-Aid mixture. Okay, so the stuff that dissolves is the solute. The stuff that does the dissolving is the solvent, and water is the most common. They call it the universal solvent. Okay, anytime you have water as a solvent, another name for it is called an aqueous solution. Okay, dissolved in water, that's what it means. Okay, and again, water's very versatile because of its polarity, its ability to pull things apart. Okay, so we have when an ionic compound, when we have salts, things like that, because they have positive and negative ends, and we have a positive and negative end with our water, it just pulls it apart. And they call that the hydration shell. And like I said, water is awesome at dissolving ionic compounds. Okay. And here it shows you how the water, here's salt, and it'll just break these little guys off and surround it because of these negative and positive ends. You can see the negative ends surround the positive, and the positive surround the negative. Okay. So some people believe that when we developed water, that's when we started getting more of our life. Okay, so to date, there's more than 200 planets that have been found outside our solar system, and there's some evidence that have a little bit of water vapor, but in general, they don't have the water like we do, so they don't have the life. You guys, I don't know that much about what's out there. I have enough trouble with what's in here, but that's what they say. Okay, so in our solar system, Mars has found a little water. I don't know any more about it than that. If you're really into astronomy, ask Mr. Wiebe, he can tell you. Okay, so we have some issues that cause threats to water quality. We're just about done, you guys, and we're almost done with this. So I'm just going to kind of go through these quick and have you guys read through them. You can just stop it. But again, you look at this as acidification. I don't know. Maybe we'll do one